So, before we start, I am well aware that we are before lunch. We will be the first group. I won't be too long, don't worry. So yesterday was a bit more about like the concrete technical part. Today is more a bit like the fun part. What is observability? What is not observability? Why is everybody using it in a weird way? And what can we make out of that? I have one or two slides that you will kind of remember if you have been here yesterday, but we'll put them in maybe new context. So let's go. I work for Elastic, as you might know. I used to mostly travel around. Now I sometimes travel around, and we try to kind of like figure out how stuff works and what are all the buzzwords. So observability is kind of like one of these buzzwords, and we're trying to look into that. And just starting like yesterday, everybody is using logs, right? More or less. Print what happened for each occurrence on the component level. So at this point in the code, something happened. Next up, loads of us are probably using metrics. You have this periodic measurement of some value, and it's aggregatable, which is kind of like, it's a nice attribute that you can have lots of data points and you can easily aggregate them. So you can, for example, roll them up. You, after a week, say, oh, I don't need 5-second intervals, but I only need 1 hour intervals of some measurement, and you aggregate them together. Finally, tracing the distributed traces, the record, the activity per request on the application level. We have done all of that just to remind us. So, you might have heard this thing that observability is logs, metrics, and traces. Who agrees to that? Okay, only 2 or 3 dare to raise their hand. We will come back to that question at the end. So the question is like, what is observability? Because so many people have been using it. And then maybe you have seen this graphics here, which is very common or very widely shared. It's from early 2017. And you see these 3 things, logs, metrics, traces. And then you have all these different areas of intersection. So for example, if you have tracing and logging combined, you have request scoped events. So I was alluding to that yesterday already, and we'll come back to it again, that you don't have like log lines, but you want to have richer events which tell you more. And request scoping basically means you have that unique ID per request. So you actually know like these are all the logs for this specific request. And you have then request scoped events. You can have metrics and you can have request scoped metrics. So all the metrics collected around one request could be aggregated together as well, or at least like shown next to each other. You can have aggregatable events. So if you have these richer event structures and you have some explicit fields that are machine readable or workable, you could make them aggregatable, but then pull them out of your log events. And then in the center, you have request scoped aggregatable events. And this slide or this thing here basically means, or some people say, and we can agree or disagree on that this here is kind of like observability, and it's built on these 3 pillars, logs, metrics, traces, which is something a lot of people say is true, and others violently disagree. Or maybe not violently, but others strongly disagree. And there are reasons for it, and observability is definitely built on these 3 things, but it's a bit like saying that the Formula 1 is built on gasoline, motor oil, and tires, which is not exactly wrong, but this is probably not the point of Formula 1. Like all of these things are, and this always stops my presentation as well now. Formula 1 is maybe built on these 3 pillars, but that's not really the essence of Formula 1, right? Or maybe some of you watch Formula 1 to see more tires and gasoline and motor oil, I don't know. But it's a bit like the same thing for observability, where you try to have these 3 things. Yes, they are there, and they are definitely used, and otherwise it wouldn't work. But it's not really why we do this or what we try to get out of it. And then I'm kind of segueing away from this and say like, haven't we seen this thing before where there is some practice and then suddenly everybody tried to turn it into tools? And for me, that's pretty much DevOps. And then when people say DevOps, it's not about whatever DevOps might be, but it's just like all the tools that you have, and then you combine all the tools, and then that's it. And I don't want to say like these tools are the pillars of DevOps, but they might be in that mix. And why did we need to put them into that mix? Mostly probably because we went from pets to kettle. Is that something everybody is aware of or knows where that is coming from? Or let me give my example. Like I remember a long time ago when I got my first virtual server at some provider that probably doesn't exist anymore. It was my pet. It got a name. I raised it by hand. If something broke, I had to fix it because there was no way to recreate it again because it had grown over the months and years, and I had run so many commands that nobody could ever recreate exactly what I had there. So it was a pet. It was irreplaceable. As an industry, we then figured out that maybe we don't want to have pets, but we want to have cattle. And the idea of cattle is that they don't have a name, they're not raised by hand, but automatically, and when they get sick, they get discarded so they don't infect the rest of the herd. And that's how many of us say that this is how service should be treated. And that's also kind of like that cattle movement where everything is automated and has like the automated name and it's not raised by hand or anything, allowed us to move from that static monolithic architecture where you have that hand-raised thing and then you deploy your application onto it, to go to this thing, that elastic microservice architecture, whatever that might be, and however that looks for each one of us. That's kind of like what allowed this move to have these highly dynamic and scaling up and down and distributed applications and environments. Which then leads me to the slides from yesterday that you have seen these, that previously when you had their monolith and their pet server, this was very simple to monitor. You could just tail F the logs on that one server. Nowadays, it's much more complicated because, well, you have this dynamic microservice architecture and you have no idea what is happening anymore. And then your software vendor, who might look something like this, is already rubbing his or her hands of what they can sell you today. And then all the discussion is about tools. And then it's tools, tools everywhere, which then turn into this thing which I find fascinating in DevOps, is that DevOps is tools or jobs or departments, which is a very interesting development because like originally I thought that DevOps was about breaking down the silos and suddenly you have DevOps teams. But well, you can always sell something like that. Why can you sell it? In part, because we are also to blame in that and are part of the problem. Because if you look at the US salary index for system engineer, you see the salary range is around 100K. And then if you move that to DevOps, you suddenly see that you can increase your pay by almost 20% just by changing your job title. So all of us want to be DevOps now, right? And we forget about like what is the idea of DevOps. Let's just say like we are DevOps and we are earning 20% more tomorrow. So that's when you end up and say like we should do DevOps. And now, this shouldn't surprise you, the next thing is that everybody says like we should do observability because that's the hot new thing, and then we can probably charge 20% more for our tools and everything. So now everything is observability. And then you get the people who might look something like this, who just watch your infrastructure. But joking aside, so what is observability? Because I basically have told you a lot of like what is not observability, or kind of like why is a lot of stuff like going the weird way. So where's the name observability coming from? There's this thing called On the General Theory of Controlled Systems, so it's from control systems, and then it says a system is observable if the behavior of the entire system can be determined by only looking at its inputs and outputs. So you kind of like have a good overview of how a system behaves by just looking what is going in and out. And you can say yes, maybe. Maybe you have seen this slide about known knowns and unknown unknowns, and there are basically 4 areas where you are, or where you can be mentally. So the known knowns are things we are aware of and understand. Does anybody know what that could be? These are like the dashboards that you're building for your application. that you know the things that will be breaking or that you need to monitor, because that's where your application is frequently breaking. And it's like scar tissue. It's like the things that you have learned from pain in the past, and then they end up on a dashboard. And then there's this joke that there are not enough interns in the world to watch all the dashboards that you have built. But that's a bit of a different topic. So, known knowns. Then you have the unknown knowns. Things we are not aware of but understand. So these are things that we haven't seen breaking before, basically, but we are generally aware that there could be an issue. That is something where people like to throw around like ML ops, AI ops, whatever. It's like where you have basically a model and the system might learn over time what is normal and what is not normal, and then it alerts you when something is not normal. So you have a rough idea that there's this thing that we should take a look at. We don't really know what it looks like, but maybe let's keep an eye on that. Then we are kind of aware that there could be something breaking in there. We're not really sure how it's breaking or why, but we kind of have this feeling there might be something breaking in there, so we might have some alerting or anomaly detection on that. Then there are the known unknowns, things we are not aware of, but things we are aware of, but do not understand. That's normally when you monitor much more than you need today. So you just collect like more events, and you just combine more data so that you can actually drill down and search once you have a problem in the kind of like set of data that you've had before, just to correlate more and figure out like what is going on. And then the bottom right is kind of like that is the main problem area, the unknown unknowns, things you're not aware of and do not understand. And that is kind of like where some people say like, this is what your observability is about. So you can collect all of those raw events and you have as much rich information as possible, and you collect everything that is going in and out of that system to figure out what is potentially wrong. Even though you don't really know why it's failing, you have never seen this failing before, but you can determine it just from the information that you collect. You see, or you might get an idea what is going wrong there. Which leads me to this nice topic of survivorship bias. I'm not sure if anybody has seen that. So it's kind of like a classic, and it also makes sense once you've heard it. So in the Second World War, I think the Americans analyzed the planes that were coming back for bullet holes to analyze like which one or where should we reinforce the planes to make them like give a higher chance of return. And the naive assumption is like, the red dots are the bullet holes. Where do you reinforce that? Where do you reinforce that? Where the bullet holes are, right? That's almost like that scar tissue. And then you think about it, and then you realize, well, actually, the planes that are not coming back are the ones that I'm interested in. And so if you have the bullet holes here or here, those are the planes that are not coming back, so I cannot count the bullet holes. So probably I actually want to reinforce the plane there and not where all the bullet holes are. And that's a bit like that monitoring versus observability. It's like, yes, you can monitor more and more stuff of like where you find the bullet holes, but that might lead to those blind spots or that survivorship bias where you're like, the things that you understood, you keep monitoring them better, but if it fails in a weird way and nobody understands why does it even fail, then you forget about the incident and bury it and nobody wants to know about that anymore. And that's still the planes that crash, basically. So the thing that you want to expose is what is the status of my system, what is not working, and why is it not working? So you want to figure out like, why is something happening so I can learn from it in the future. It's a bit like comparing, or this nice comparison saying that monitoring is when your bank tells you that you don't have any money on your account anymore. And observability is telling you you're running out of money because you're buying all the chocolate cakes and sweets, and that's where you spend all your money. So the monitoring is kind of like your system is down, and the observability is more about like, why is your system down and how did that happen and how can you fix that going forward? There's another take on that might be slightly small, but basically you have some data coming in and you have, this is the monitoring side, and this is the observability side. And the general structure and approach is very similar. But what you're doing here is you are counting something and aggregate it, and then you have an expiration function, and then you have some expiring metrics that you collect, and then you see this is the error rate, and this is the response rate, and whatever. So you have an idea when your system is working and when it's not working. And then out of that, you build a metric dashboard, you have some threshold checker, and maybe some alerts, and that is how your classic monitoring system works. And for the observability, you have the kind of like raw data that is coming in. So you have events, and you can kind of like get more information out of those events. You still have an expiration because you don't need to keep your data forever. And then rather than having that preset dashboard that your intern stares on and says like, now the curve is different than it was yesterday, you have something where you can slice and dice and search your data and just like drill into it to get more out of that. And then you have not just a static threshold, but more like pattern matching, or maybe something that has learned over time like how that curve should look like every day of the week. And then you have alerts based on that. So this is more about like, it's working, yes or no. This is more like, what is the cause behind it? And we could have this entire discussion about, is there a single root cause, or is that like a misguided principle to always look for a single root cause? But that's kind of like the idea that you want to collect all these raw data, inputs, outputs, to then say like, this is working, or this is why this is working or not working. Which then, of course, leads us to the vendors again. So maybe we have seen this move before. You put whatever crappy software into a container, it's bang, it's cloud native. And it's kind of like what the monitoring vendors are doing, like we have these monitoring tools, so now we have to rebrand it as observability tools, and then they will just keep selling. It's just like putting your COBOL application into a container. Which you can do, but that's maybe not the point. Anyway, so to instrument, the idea here is, and there was this OSMC talk yesterday, for example, that might be a good example here is, or OpenTelemetry in general, without shipping new code, you want to understand what is going on. So you know your system. And that's one thing that, for example, if you add manual log lines, normally when you have a bad problem and then you redeploy your application with more logging, the problem just magically goes away. And you never figure out what actually happened there or broke. So the idea here is that you don't need to redeploy your application because, or maybe that's the ritual of how you fix stuff, and if that works, fine, but that's not the idea of observability. You want to kind of like know why something is happening. The other thing here that is kind of, I think, important to remember is if you want to keep your systems healthy, it's not the way to only look at them when they are failing. It's almost like trying to learn how marriage works by only looking at divorces. Because that's what we are often doing in outages, right? We only look at all those dashboards that we have created when stuff is down, and we don't even know what they should look like. We just know something is red, and the CIO or whoever is standing behind us and shouting, and then we need to figure out what is going on here and why it's down. So if you only know your system when it's kind of like in a bad state, maybe that's not the right way to learn how it should be behaving and how your system should be looking like. Which turns then into like you want to monitor and collect and log and trace and whatever, all the things. But on a side note, not all things are equal, especially from like an end user perspective, and that's normally what many of us are looking at is, some things are very important for an end user, like can I log into your application? Can I do a successful transaction in a shopping cart or whatever? Can I do a search operation in a performant manner? Can I buy something? Can I put it in the shopping cart? These are things that the end user cares about. The end user doesn't really care about if you have like some API error, but your UI will just like hide that UI element that is relying on that API. Your end user doesn't really care. You don't need to wake up somebody at night for that. Your error rates, if you have like some automatic retry and nobody really notices, your end users also don't really care. If your database query latency is going up and before it was like 1 millisecond and afterwards is 5 milliseconds, yes, it's 5 times as bad, but probably your end user is still not going to notice that. So while you can collect everything and then alert on everything and then you will be woken up 3 times a night, that's also probably not the point. Which then leads to service level indicators, objectives, and agreements. And I assume you have seen those before as well. So the service level indicator is, for example, the thing that I'm looking at here is like uptime of my service. And then we have an objective where we say we want to have this at least at 99%. And then the agreement you have like with an internal team or with an external player or whatever is, like if the uptime happens to be less than that objective, you owe me money, or I owe you money, depending on how you see it. But this is kind of like the idea how to see that, why you have these things that you want to agree on. How should your system be behaving in general and not just when bad stuff is happening? But uptime is also this thing where everybody says like, what is the uptime that you need? And then you ask somebody who is not from the tech side, and then they will say as many nines as they can imagine. And that's maybe not really that important. So for example, I don't know how much you're using GitHub, but GitHub has this tendency to go down more or less frequently or have some failures. Yet, GitHub has been acquired for a lot of money by Microsoft. They still have that downtime. Everybody still uses GitHub. So if you say my application needs to have like 5 nines, maybe your application actually doesn't need to have 5 nines. Because people seem to have a higher tolerance for the right product that solves problems, even if they're sometimes down, than you might expect. That does not apply if you make pacemakers. I remember there was once a big AWS outage, and there was somebody saying like, oh, we are monitoring pacemakers and we were using a single availability zone. Please fix our stuff now. And that availability zone happened to be down for a couple of hours in that day. In that case, uptime is more important. But your average cat picture application probably can take more downtime. And then the thing that the vendors don't want to hear or don't want to say, I guess, is that you cannot buy observability. And that leads me back to that example from yesterday about logs. So this is like the classic log line. And you can read this, and this kind of makes sense. And I have some standard information that you might have in your Java application. Then, if you add some more structured information, like you have this event category, and you have a username, and you have the source IP, with those, which are also aggregatable, you can suddenly drill down into your data and understand much better what is going on. Because from this one here, you will have a very hard time figuring out what is even the IP address? Is somebody trying to brute force my system? Is it one user account where everything is failing? Even what is the success to failure rate on my login? You will need to read all those messages, and you need to make sense of them. With this, you can suddenly see, is it one IP address where everything is failing? So block the IP address. Is it one user account that is being affected? Maybe support should reach out to them to say like, hey, your login is failing. Do you need help to reset your account? Or you can suddenly do a lot more things if you have like these richer information structures, rather than just seeing like, okay, a login failed. Yes, with monitoring, you can tell that the login is failing. The idea here is if you make those richer events, you can suddenly tell what is going on and you can act on that more. It is more information, and it's not going to be automated to have the right things extracted here to make sense. So this is something you cannot just buy, but this is something that you need to build correctly to collect the right information to make sense of the data that you are having. And then there are all these other things. So you might have health checks, or you might want to check security, or maybe alerting is bigger for you. So it's not just logs, metrics, and traces as the pillars, depending on who you talk to. If you talk to somebody who is selling an alerting solution, for them, observability is all about alerting, because what good is it if it's down, but nobody knows, and nobody gets woken up. So it is also very much about the view of where you're coming from, what observability really means. And as always, the goal should be the business value that you deliver. It's basically, if you have that system and you have all of that monitoring data, but you don't bother to use it, it's not going to be much good, like if you have just all the data collected. So, to wrap up, monitoring is more about seeing if the system is not working, which is a good first step. Observability is more about why is it not working. So it's the reason behind why something is breaking and to figure out all the things that you didn't know from the system from before. You want to be able to answer those and then come to a conclusion. And you can repeat after me. You cannot buy DevOps or observability, though I can totally sell it to you. Luckily, we don't have any vendors here that seem to sell observability or DevOps, but I have been at events where this was the case, where every second vendor was trying to sell DevOps to some degree. With that, we have like 3 or 4 minutes left. Any questions? Who still thinks that observability is logs, metrics, and traces? Kind of, okay. A partial conviction now. It's the beginning, okay. Yes, but like the Formula One example, like it's there. You won't have Formula One without tires and motor oil and whatever. You won't have observability without logs, metrics, and traces. But that alone is maybe not the idea of what is different. Questions?
If there aren't any more questions,
then you can lunch.
Observe me giving you yet another pack of snacks.
Thank you very much, but not before lunch.
Yeah. Afterwards.
After lunch,
Thank you,
yes.
Philipp.
Thank you.